Hi everyone, I'm Whit Roy. In this lesson, we'll explore the main calculation topics that may appear in the EWRB Electrical Service Technician Theory exam. The most common types of calculation questions in the EST exams include heater current, resistance, power, voltage drop, fusing current, fault current, and more. Let's begin with the most common, finding current in a circuit. We start with the most basic formula, current equals power divided by voltage. It helps us find how much current a heater or any load draws from the supply. For example, a 2 kilowatt heater on 230 volts takes about 8.7 amperes. Sometimes we know the voltage and power, but we need to find the resistance of the heater element. We use R equals V squared divided by P. For example, a 230 volt 2 kilowatt heater has a resistance of 26.45 ohms. This value helps check if the element is within normal working range. If we know the resistance and the voltage, we can calculate the power used. The formula is P equals V squared divided by R. For example, with 240 volts and 30 ohms, the power is 1920 watts. This is useful for estimating heat output or energy use. Every cable has resistance, so voltage drops slightly along its length. We use V drop equals millivolt per amp meter times current times length divided by 1000. For example, an 8.7 amp heater on 15 meters of 1.0 square millimeter flex will drop about 5.6 volts. That causes around 49 watts of power loss in the cable. A fuse's fusing current depends on its rated current and fusing factor. Use IF equals rating times fusing factor. For example, a 20 amp GG fuse with factor 1.6 will blow at 32 amperes. Always check fuse type. GM fuses have higher fusing factors. When a short or earth fault occurs, we calculate the fault current with I equals V divided by R. For example, a 230 volt fault loop of 10 ohms gives 23 amperes. That's enough to cause serious damage, so protective devices must disconnect quickly. Our AC supply is measured in RMS, but its peak is higher by square root of 2, so V peak equals 1.414 times V RMS. For a 230 volt supply, the peak is 325 volts. That's the highest voltage reached in each half cycle. Standards allow a maximum of 5% voltage drop for fixed wired equipment. Use V min equals V nominal minus V nominal times 0.05. For a 230 volt supply, that gives 218.5 volts minimum. Below this, equipment may not operate safely. Motors and inductive loads draw more current because of their power factor. Use I equals P divided by V times power factor. For a 1 horsepower motor at 230 volts and 0.9 power factor, current is about 3.6 amperes. Good power factor means less wasted power. When combining elements, add resistances in series or use the product over sum rule for parallel. For example, two 40 ohm elements in parallel give 20 ohms total. That's how heaters achieve low, medium, and high settings. To find power in one part of a circuit, use P equals 1 squared times R. If a 2 amp current passes through a 60 ohm resistor, power is 240 watts. It's an important step when checking heat or overload risk. Ohm's law is the base of all calculations, V equals 1 times R. If voltage is 230 and current is 10 amperes, resistance is 23 ohms. Always check this relationship. It appears in almost every exam. AC frequency is how often cycles repeat. The period is 1 divided by frequency. For 50 Hz, the period is 0.02 seconds. That means each cycle repeats 50 times every second. 1 horsepower equals 746 watts. So a 2 horsepower motor uses 1492 watts. We use this conversion when sizing cords, fuses, and switches for motors. When current flows through resistance, some energy is lost as heat. Efficiency is output power divided by input power times 100. For example, a 2000 watt supply with 1900 watt load has 95% efficiency. Less voltage drop means better performance. Always compare the calculated fault current with the fuse or breaker trip rating. If the fault current is greater than the fusing current, protection will operate. If not, it will stay conducting, which is unsafe. For example, a 32 amp fuse won't blow at a 25 amp fault. In New Zealand, the MEN system connects neutral and earth together at the main switchboard. So, neutral to earth is 0 volts, phase to neutral is 230 volts, and phase to phase is 400 volts. That's our standard domestic supply. Two-element heaters can switch between series and parallel. At 230 volts, if each element is 46 ohms, series gives 575 watts, one element gives 1150 watts, and parallel gives 2300 watts. That's how low, medium, and high work on your heater. We've covered 18 types of EST exam calculations, from Ohm's law and fuse current to voltage drop and power factor. Mastering these formulas will help you solve any EST exam question with confidence. Thanks for listening. I'm Whitroy. See you in the next lesson.